on. So Replicator G is going to be a software that you guys are going to need eventually. So the reason why is you can still do all the work and set your files up for printing without having the printer. So this is a open source 3D printing program that allows you to 3D print to our machine, the MakerBot. Yeah. This is what the software is going to look like. I don't know what version I have. Oh, it's 4.0. I have the newest version. Okay. So it's 4.0. So that's the new. That's as far as they got. So this software here is a software that both allows us to set up the 3D printer, but also set up the 3D print. Okay. So we'll get to this. This is a free software. You can download it. If you type in Replicator G, it'll bring you to replicate.org. Download. Take the newest version, obviously. Okay. And this is going to allow us again to go ahead and start making our slices for this. All right. So what happens with a 3D printer? So let's go look at our model. And we're going to pick one of these. We won't pick the most complicated one. Maybe we'll pick this one. This one has... But I'm going to go ahead. I'm going to save this real quick. And restart because this computer is having some problems. Others.
So the honey is honey. So first is has to have the honeycomb.
So what it does is the software generates all the cut lines, and then the printer just prints each one on top of each other, layer by layer, layer by
But
layer.
inside is the honey.
And inside it does a honeycomb.
So honeycomb was supposed to be first, yes?
No, same time. So it builds each layer at the same time. Okay? So if you can imagine, if we had something solid, and you'll see it in reality here in a few minutes. So if we wanted it to, if we had something that was like this, right? And we slice it, one of the sections would look like that, right? A bunch of circles, and it becomes smaller and bigger. So what this thing does, it prints sort of the outside as a solid, two pieces, and then it starts filling in the inside, right? So it's running. Right? There's another outside. Moves up. Yeah, if you hold that up, you can see it in the light. So it's just sort of working each section at a time. It can't go back in because it would hit the nozzle, would hit the part. So it's building layer by layer. Yeah, the honeycomb is just generated so it's not solid, so you're not wasting material, right? And it's faster. Yeah, and it's strong and it's faster. So it's not hollow on the inside. All right, so if we were to pick, so what I'm going to do is pick one of these shapes, all right, and take a look at it. Now, the one thing that we have to take care is if we have if we start doing overhangs like this, right, those should work. We should be fine. But if we do a graceful sort of overhang, it's going to be okay. And tops can be flat. Problem is, this material is being built up like this. If it has nothing to sit on, it'll just fall. So if you're trying to do a chess piece that does like this, straight out, it'll try to do this as a straight piece and it'll just fall. Okay? Now we can build support material. The problem is I haven't seen like a successful support profile for this machine. There's an option for support material, but it doesn't really do a good job. Oh, that's
So the support material, you would design that in your initial design or within this print software?
It does it all for you. Yeah, it does it all for you. I mean, you could do your own, you know, like put some supports in, but and this would be too difficult, right? Because you'll never be able to pull it out. So that stuff, like the support material, is really loose filament, so you can pull it out. Okay. So that would be the first thing, you know, to take care, you know, like you don't have too much of an overhang. And we'll see how this one works. We'll see how it goes. All right. So the next thing is we need to export this out. Okay. So we're using a stereolithography file, STL. Okay. Now we don't have to export it out at 0, 0. Eventually we can move it to 0, 0. What we're going to do is select it, export selected. And we're going to pick STL. So we're going to look for our stereolithography. So this file is used for 3D printing. All right. So this is the file that we want. And you'd have to do for each piece. In this case, we're doing one piece. We're going to leave all the default. So we can just go simple. Just leave everything whatever default it is for the export. Default, default, and we're done. Okay, so after you're done baking your piece in, we just export one at a time, right? So you select one, you export it. We then can go to the Replicator G. So when we open up Replicator G, this is what the software is going to look like. Okay. Now I have my computer hooked up to the printer, so it's connected. All right. Now before we even start messing with the printer, the first thing you want to do is go ahead and open up that STL. So we're going to go to the desktop and we'll find Nolan's and hit OK. And the first thing you'll see is where did it go? It's tiny. So this software works in millimeters. Okay, it's no big deal. We'll be able to fix that. If we go to scale, inches to millimeters. So we want to convert our inches to millimeters. So that's how big the piece actually is. This is right click. This allows us to spin. Okay. The maximum height, I think it's 4 by 4 by 4 basically. Okay. And let's not get too big because they will take a while to print, and we want to get some out every so often. So that's been scaled. The other thing is it does typically put it on the bed. And it does center it automatically. All right. So after we're done with that, there's a generate G code here. We're going to click on that. It'll ask if we want to save it. We always save the STL. And then we'll start to be able to generate in the G code. Just thinking. So part of this replicator, you're going to need to download Python. If you follow the instructions on this page, I think Python comes with all of this, so it should all load. If it doesn't, yeah, we'll have to see what happens. It's been a while, but I think it should be fine. It should all work. So I have 2 versions of Python. Python is what's doing the cutting. Okay. So we're going to hit OK. I don't know why my machine is hurting, but it is. So the next thing is what type of slicing profile. Well, this is the cupcake with heated base platform. So there's a heated platform. The reason why there's a heated platform is we're printing ABS, and the ABS will tend to shrink if it cools too fast. Like by the time it gets to the top, the bottom is going to be really cold, so it will start to shrink. Okay, you can see that happening. This is PLA. You can see it shrink. If you put this down, the PLA has tendencies to shrink less, but because this part was so big and there was too much air movement in the room, the bottom was cooling too fast and it started shrinking and pulling it. Yeah. Okay. So that bed will typically avoid that. We want to use raft. A raft is it's going to basically build a little raft that this thing sits on. That helps the adhesion. We want to get rid of no support. This never do. I've seen the support on this. It's not very convincing. Okay. And then there's a default and start end. That's fine. We don't have the Print-O-Matic. That's the stepper extruder, which I wish I could have upgraded this, but we don't have that. And then we hit generate code, and this thing will start slicing. Okay. So this is generating G code. So all these machines are going to be run by G code, some type of, and the G code has to be formatted in some fashion for the machine. So there's certain start commands and so forth that this machine is looking for. All right. So again, I'm not sure. I'm going to go ahead and close Rhino now. I don't know why that opened. We'll close it. Go ahead and close.
So this imaging really is just the presentation part, right?
Yeah.
Nothing to do with-
No. Yeah, just for presentation. So starting the slice. And typically it won't take that long, but the problem is this machine, I don't know, something happened between. Yeah, I built this. This is a kit, yeah.
Is there a way to set the thickness of the slices?
You can, but it's based on the extruder tip.
Oh,
So it's point, I believe it's 0.4 millimeters. That's the tip that's on there. So the height of the slice is 0.4 millimeters. Okay. I don't know what's 100 microns? That's like always, let me pause this. So once you're done, you get the G code. And this just like gets the machine going. There's a couple things like it knows where it's at 0, 0. For some reason, it maybe I just need to get rid of this altogether, but we need to get rid of this part of the G code. Okay, this is like a preheat up, and it'll just never go. It'll preheat, it'll get to the temperature, and then nothing will happen.
Why did it go all Star Wars on us
Where?
though? You failed me for the last time you did not.
Yeah, it's just something they write in the code, so we're gonna delete that. So basically, it's telling it's telling at 0, 0, and then it says go to 0, then it starts going. Okay. So it turns on the motor. These are all commands. You don't need to learn G code. If you want to, you can get a book on G code. Yeah. So this is all the G code. So these are all the slices for here. Yeah. So now what we need to do is start prepping the machine. So after we have this, we save this. Okay, we have the G code. We're then going to go to machine. By default, it's always going to pick the right machine. So there's the Cupcake with heated build platform. We're connected to COM 11. We want to go to our control panel, which I have open already. And this is the controls, okay? So the first thing we're going to need to do is before we start making it really hot, it's zero the position. So here's our MakerBot. These are moves for the MakerBot. So I can move this thing. Okay. So this is front and back. Let me switch this to like 5. This is right, left. So the first thing you're going to do, let me see if I get the speed up. See how fast it is? Okay. This will crush your finger. Okay. All right, so don't put your finger in there. This is the Z.
Nice.
Okay.
Nice.
So you have to get this all zeroed. Now I zeroed this already, so I'm going to go ahead and put it on 0. So basically, you get it centered on this thing where the tip is just barely above. And you get as close as you can eyeballing the 0. So we're going to be always printing small stuff. Now, when the new machines come, we can go ahead, and this stuff all happens automatically. So, but this is, low tech. All right? So that'll be the first thing. So getting it. Once we get it to 0, 0, there's a button here that says make current position 0. We click that. And then this will read all zeros. All right? And then we want to lift the Z up. And this is moving 50 millimeters at a time. Now the one thing when you're moving this thing around, you got to be careful that you don't have this set to a high number if you need to move slowly. So we can set the increments, 1 millimeter. Okay, we can stop it if there's a problem because this thing will eventually, you'll break it. Okay, so you have to, if you're going to be jogging this thing around, you have to take care of it. All right. The next thing is you're going to kick up the temperature of the extruder head and the platform. The extruder head, you're going to kick it up to 200 Celsius. That's how hot that is. If you put your hand on there, you'll melt your finger. And then the platform is going to be at 120 Celsius. Okay, this is Celsius, not degrees. How hot is that in degrees? Still very hot.
Fahrenheit.
Yeah, in Fahrenheit, sorry. That the conversion of it. Look it up, you'll go, wow, that's hot. Yeah. It's very hot. Okay? So that will melt your hand. Alright? So we wait till that heats up. This is giving you the reads. So there's there's 2 thermometers in this thing. You can see the set temperature is to the left, the current temperature is to the right. I've preheated this. This thing is, already preheated. Okay? It'll take about a couple minutes to get that hot. Alright? So this thing is nice and toasty. So you can cook an egg on there. Yeah, it'll drop and then it'll kick back up. So
It always is there.
I think it maybe once it goes within a certain, see how it turns back on now and it's heating it up again. So yeah, it has a flux. It fluxes up and down a little bit, which is fine. We don't want it too hot in the beginning because we have no material in there yet. So it's going to run at about 210, 220 the whole time.
Can I print out a small Pikachu?
Pikachu figure?
If you whatever you can 3D model, you can print. Yeah.
I can't print Pikachu.
So you have to make a 3D model. See, that's why you got to learn how to model.
It's a little copyright infringement.
All right. So the next thing is, guys, right on top here, there's a inlet. All right. This is our ABS. We place this in the inlet. Okay. We jam that down. To the right, here's the only time we're going to be putting the machine. This is where you don't want people messing around. There's a knob here on the right. You want to crank that down until you really get it. So we're basically pinching this onto the motor, okay?
Can you feel how high it
Yeah, eventually you won't be able to turn it. Okay, so really crank it. You don't have to over crank it, but you can crank it. All right, so now we have the material. Now we need to start feeding it. Our motor speed is in PWM. We need to set that to 255. That's full speed. And we're going to go to forward. Okay? If you listen, you can probably hear, and eventually you'll see material coming out of the tip. So it's instantly melting it, yeah. It's so hot. Eventually, once it goes in there, it'll just come out. You can see it coming out if you have some white paper behind. Okay? So the first thing is we want to sort of get it ready. So we're sort of prepping the machine right now and getting the material flowing, yeah? Ready to make the donuts. We'll see what the build time is. It'll tell us approximately.
So this isn't actually building.
No, this is just prepping the machine. Okay? So once we're pretty happy, we're going to stop it and reverse it a little bit and then stop it. So we're reversing it so it Doesn't, you know, like a glue gun, when you push it, it still comes out. Now you want to be really careful. We're going to pull that out, okay? So I reversed it, so I stopped it. It's still going to ooze out a little bit. We're going to go ahead and put that down again, zeroing the Z, okay? So we're going to get this thing down now as fast as we can, which that's as fast as we can. Okay, looks good. We're then going to send the G file. So this is send the G code to the machine. This little button here. We're going to press that. It's going to start right up. And there's going to be a couple things we're going to need to do. We're going to keep an eye on the height. So the height looks pretty good. We're going to fine tune it. So this is up. We're going to take it up a little bit. You can see already it got stuck. So that's a bad, so you'll have that where you get a sort of a bad print maybe on the first one. Let's see if we can get it going again. I like lifted it up too far. So we'll try to, I think we'll be able to save this. I'm gonna lower it a little bit.
That's just kind of a manual, just.
Yeah, so the first one's always a little bit tricky. That's the plate coming on. So that looks good, that height. So you see how this is like a real crappy bead? So this is what's called the raft. So this is the raft where it's going to sit on. Eventually, if you get, is there an X-Acto blade over there, you think? Or does everybody have their knife blade? Usually I have some tools with it, but today I don't. When this thing comes forward, we can probably snap this guy off without screwing that. No. Alright, so we're going to stop this. We'll stop this build and then restart, which is fine. So say, okay, I'm disappointed with that. It's alright, it's going to take, trust me, you're going to get a lot of these. We can stop the build, okay? So we'll stop it. We'll go right back to the control panel. We're going to go ahead and get the Z up. I'm going to get the temperature back up, so we got to sort of set these things up again. I'm going to 0x, 0y, and then I'm going to get the motor going so it starts extruding again, so we don't lose. So he's going. And then we're going to try to get this off the back. Yeah, we lowered a little bit. So you can see that was a pretty good raft that was going there when I, stopped it. So I overdid it when I lifted it here. So actually, I think it was doing fine where I had it. I think I had the Z located really, really well. Now, the reason why I keep on feeding right now is because what's happening is if we just let the material sit in there, it'll just start getting so hot, it'll just not want to come out. It'll start bubbling inside there and get globby. So I'm just sort of like, okay, let's keep the process going. I'm going to go ahead and re-zero Z while it's going out. This is, again, once we get the new machines.
A lot of like manual tweaking here.
Yeah. But it's good. Then, once you get once we get the other machine, you'd be like, hey, I know how this works. So at some point, once I get there, I'm going to stop it, reverse it, stop it, try to get, it looks like there's a little bit there. Let's lift it up real quick. I'm going to borrow your knife again. We're going to try to bust that tip off. Because we don't want any interference.
This machine is on manual.
Yeah, the other one is a push the button and go.
Oh, okay.
This is a little nicer because you do have that ability.
So how old is this machine? You said
2009.
yeah.
Oh, come on, Teflon.
So when you,
So in this machine they had Teflon, which was a big mistake. Alright, so I'm going to bring that 0 to Z again. So we're going to try to get this thing started. So I'm gonna come back in. Should go in a second. So the height is actually good where I have it set. So I don't think I need to adjust it on this one. I might need to lower it. Alright, so looks like that's good stuff. Alright, so that's pretty good. So it's gonna do the raft. That's the first thing it's gonna do. And there'll be two parts of the raft. There'll be this part, and then it'll do like a loose sort of grid on it.
And that's something you can just break it off of.
Yeah, at the end you break it off.
That's kind of
So
nice.
you can see how thick the resolution is. It's a little thinner. It does squash it a little bit. And I haven't fine tuned this machine recently. Like there's a newer head which is a lot better. It's with the stepper motor, so it's a little better on the speed.
The future of tattooing probably too, too.
You know, like don't they do laser tattoos yet? I think people have made it, no? I mean, you gotta get ink. No, I think tattoo artists won't let that happen.
Plus it's, how would you lay it under the skin? It's kind of
It
built.
would have to be like needles, like.
If they made this happen, fuck, they can make tattooing happen.
That's true.
Yeah, they might have.
They've been doing food with these though. That's what I think.
Yeah, you can do a frother, so you can put like food, 3D print food.
Like
Well, they just printed-
viscous
they-
foods. Yeah.
I mean, the big thing is they print organs.
yeah.
We're working on that. That would be the future. It's like, oh, I need a new ear. Print you an ear.
Let me get a skin sample. Because I was talking with, because I work in a restaurant, and I was like, talking to my chef, see if we could 3D print plates with our logo, and that way you can do it. But a lot of the material you're using is not
Toxic.
safe to eat on, so
Can't eat on.
really hard to find.
But you can do ceramic. You can do plates, and then you gotta glaze them.
Oh, okay. Okay, that makes
You
sense.
look into that, like in pottery, like.
Yeah, what are they
3D.
using for a binder for a lot of these newer like, 'cause I know they're doing like stainless steel and.
Oh, it's just laser. It's just
Concrete.
melting it. Melting
It's
is
just
never
that
metal.
hot.
It's
But like,
just-
the
kidding me.
concretes and the like bricks and stuff, I know they're using that.
They're mixing.
Masonry.
They're mixing. They're injecting concrete.
It's just-
Yeah. So like this is concrete,
Right.
but at a
lot of
bigger.
latex and.
So does it have more of like a mixer? You mix a liquid.
I guess
Concrete
they like
or-
already extruded it and.
Or is it
So we'll get a
solid?
build time for this, and I probably should stop recording. Wow, 1 hour,
10 minutes.
10 minutes. So this thing's really big, right? Well, we'll see. I'll stop the recording. So yeah, that's the settings, and then we'll see in the end.